In this video, we are going to discuss various examples based on the properties of ROC. So consider the first example. In this example, let us suppose it is xt is equals to delta t plus capital T and plus delta t minus capital T, right? For this you have to find the Laplace transform using the Laplace transform properties. So as you can see that this function delta t plus capital T is shifted by a factor of t. In the second term it is shifted by a factor of minus t. So for this you can apply the time shifting property, and according to time shifting property says that if xt has a Fourier Laplace transform x of s, then xt minus t naught has the Laplace transform x of s e to the power minus st naught, right? For this you will, if you consider the ROC is r, and for this ROC will remain the same, right? So as you already calculated the Laplace transform for delta t function, so that for delta t function the Laplace transform is 1, right? If it is 1 means independent of s, and then for this ROC will be the entire s plane. Entire s plane means if you draw in s plane, the entire s plane will be this for delta t function, right? Now you have to find the Laplace transform of delta t plus capital T. For delta t plus capital T, using this property, it will be 1 multiplied with e to the power st, right? There is a no change in the ROC. As you can see, there is a no change in the ROC. The ROC will remain same for this also. Similarly, you have to calculate delta t minus capital T. For this, it will be 1 e to the power minus st, right? And for this also, there is a no change in the ROC. ROC will also be the same. So if you add these terms, this and this, as it is added in xt function, then x of s has the Laplace transform e to the power st plus e to the power minus st with ROC is equals to, ROC is the entire s plane. Okay, so this is the first example. Now consider the second example. In the second example number 2. In this example, let us suppose xt is equals to e to the power minus at cos omega naught t ut, right? Now in this function, first you have to find out for which function you already know the transform. So this is the function for which you have calculated the Laplace transform, and it is cos omega naught t ut. You should also learn this transform pair. It is equals to s upon s square plus omega naught square, right? And for this reason of convergence, real part of s is greater than 0, right? Now as you can see in this function is multiplied with this, so you can consider the shifting in s domain property. You can apply shifting in s domain, and according to this property, shifting in s domain, if xt has the Laplace transform x of s with ROC is equals to r, then xt e to the power s naught t, if there is a multiplication of this exponential function with xt, then there is a shift in the S domain by a factor of S minus S naught. You have to keep in mind that if plus sign is coming in the time domain, then there a negative sign will come in the frequency domain, right? And the ROC for this will be R plus R is this. In this there will be a summation of real part of S naught, right? You have to find what is real part of S naught. Okay, so apply this property in this. So it will be, what will be it? It will be like, you can write it as, there is a multiplication of e to the power minus at, right, into cos omega naught t. Okay, then there will be a shift in the S domain by a factor of plus a upon S plus a whole square plus omega naught square. If e to the power minus at is in multiplication and the factor is and the sequence is defined in the right direction, either ut will also come, then for this the ROC will be real part of S greater than minus a. Means this minus a will added in this ROC according to this property. So for whole, the ROC will become real part of S. For this, the ROC will be real part of S greater than minus a, right? And this is the Laplace transform for the given function. Similarly, you can calculate the Laplace transform of xt is equals to e to the power minus at sine omega naught t ut, right? Now come to the next example. The next example is, let us suppose you have to find, example number 3, you have to find the Fourier Laplace transform of delta 2t. Delta 2t means delta t transform, you know, that is 1, and there is a multiplication of 2. It means there is a scaling in time domain, right? Then apply the time scaling property. Then according to time scaling property, the transform is xt has a Laplace transform xs, then x at will have the Laplace transform 1 upon mod of a x s upon a, right? So for this, delta t has a Laplace transform 1, then delta at will has the Laplace transform a is 2, 1 upon 2, and it is not defined in delta t, so it will be 1 upon 2. Now see the reason of convergence. For this, the reason of convergence, real part of not real part of S, it will be the entire S plane, because it is independent of 1, entire S plane, right? But according to scaling property, if the ROC is R, entire S plane according to this, then there will be a multiplication of A in the respective ROC. This is the entire S plane. If you multiply A, it remains the entire S plane. There is a no change in the ROC. It will also be the entire S plane, right? Now come to the next question. The next question is based on differentiation in time domain, right? So consider the example that you have to find the Laplace transform of the function xt is equals to d square over dt square e to the power minus 3 t minus 2 u t minus 2. For this you have to find the Laplace transform. Now first analyze the given function. In this function you need to know that which transform pair you know. So see this function. In this function, if you write e to the power minus 3t ut, and in this function if you shift it by a factor of t minus 2 ut minus 2, right, you know the transform pair for this. In this you apply the time shifting property, and after that you are double differentiating this function. Means you are applying two properties to find the Laplace transform of this function. Okay, so let's consider the Laplace transform. What will be the Laplace transform for this function? It will be, we know that the Laplace transform for e to the power minus 3t ut is 1 upon s plus 3, and for this the real part of s is greater than minus 3, right? Now you have to find the Laplace transform of e to the power minus 3t minus 2 ut minus 2. So according to the time shifting property, there will be a respective multiplication of exponential function. Okay, here minus will come, then minus will also be there in the s domain, right? But there is a no change in the ROC. It remains real part of s greater than minus 3. According to the time shifting property, there is a no change in the ROC. Now when you apply the differentiation in time domain means if you differentiate it twice, right, e to the power minus 3t minus 2 u t minus 2, then there is a respective multiplication of s having the same degree as that of differentiation, right? So the differentiation degree is 2, so its degree will be 2 in s domain, right? It will be s square and e to the power minus 2s upon s plus 3, and there will also be no change in the ROC. It will remain real part of s greater than minus 3 according to the differentiation in time domain property. Okay, thank you so much.